Hi, this instrument is a director horizon. The reference is H6. And this thing is quite large compared to other instruments. The width is about 4 inches. The weight is 2.7 kilos. This thing is not too expensive. You can find several of these instruments on eBay. I bought this one from eBay UK for 40 euros or something like that. So on the front there is an artificial horizon, and this instrument is also combined with an ILS. So you have a glide slope, which is indicated by this horizontal needle here. And there is also a localizer here. I didn't find anything on internet, there is no documentation, so I don't know anything about this instrument. So it can be a little bit complicated to make it work, but I will try to do my best in order to activate this unit. It can be interesting. So normally I think that this instrument is on that direction, because you have the symbol of the aircraft here, horizontal. On the rear we have two connectors. You can see the hidden plate here. So let's first open this thing. This thing is full of mechanical stuff. I don't know how many synchro resolvers there are inside this thing, motors and synchros, but there are a lot. So this will be, I think, difficult. I don't know where to start. We can start from this side. This is probably a DC motor, but I'm not sure. No, because this is, you can see a stator with 3 coils. I don't know if it is a motor or this is a resolver. This is a synchro transformer. You can see on this side several gears. And with some springs, so this should be, this seems identical to the previous instrument. The problem I had, this thing is a torque limiter, probably. You have another one here. Okay, so this permits to rotate this needle, and the second one, the other one. This thing is very complex in terms of mechanical stuff. So this is a small electromagnet in order to deactivate the flag here. Electromagnet is here. And this is the motor. You have the small gear here. This is also a motor generator with the tachometer in order to have the stabilization of the servo control loop. So it is always the case when there is a small gear here. This is obviously a motor. It cannot be a resolver when you have this small pinion, small gear like this. Okay, so this permits to move the horizontal horizon. The electronic side is not very large. It is a PCB, but the transistors are upside down. There is a small module here. So I don't know how to proceed. This thing is quite complex. I don't know the cost of this thing in the past, but I think it was very expensive. I cannot imagine the time which is required to assemble one unit of this kind. This thing is heavy because of the very thick frame here. You can see there is a thickness of I don't know, 6 millimeters or something like that. And the mechanical stuff also should be heavy due to the number of motors and synchro resolvers. the lock thread is very efficient. And I think that there was much more lock thread on this screw than on the other ones. That explains why it is difficult to remove this screw. Some screws are totally loose and others are totally stuck. It is very strange. Okay, so we can see two transformers. The electronics of this thing is not too complicated. It seems that we don't have any ICs, we just have transistors. So the reverse will be, I think, quite easy. What we can do is to follow the wires of the transformer. On the transformers, probably they are connected in parallel, but I'm not sure. Probably there are two different power supplies. I don't know the power supply of this thing, probably 115 volts. And the best thing, I think, is to remove all the boards from this frame here. And the same for the other side. But we can open first this shield here. It is difficult to remove because of this motor generator here. You can see that we have two boards back to back. This is similar to the other circuits. Now we can see that the boards are actually identical. I assume that we have the same boards inside the black shield here. You can see the power supply board here. So there are two diodes on this side and probably two others on the bottom side. Okay, so we have two diodes here in series, at least with one common point. And the common point is the anode. So this is obviously the negative power supply because the two other wires are connected to the transformer. This one here and the second one is here. If we measure the DCR between these two terminals, we have 7 ohms. And in between here, we have 4 ohms. So this should be the ground. Okay, so this is connected, for example, to the negative terminal of this capacitor here. So this is interesting because now I can connect an AC power supply between the ground and one terminal in order to have something like 12, 15 or 20 volts across this capacitor here, for example. And then I can check the AC power supply, which would be present on two terminals, so this rear connector. The other terminals are isolated. And this one is 52 ohms between these two terminals, 6 ohms and 6 also. So probably this is 115 volts. So I can check if there is a connection between this point and one other rear connector here. No, it is not the case. This one is connected here. I have 47 ohms here. Okay, it is connected, I didn't see, it is this one. So this one is effectively connected. So this should be the 115 volt input. We have 52 ohms between these two pins. Okay, so let's try to apply an AC power supply. This is Josette. I have connected this transformer to the power supply input. At least I believe it is the power supply input. I have an assistant today. Thank you very much. So currently I have a power supply input of 30 volts. So I will measure the voltage across one capacitor. This one, for example, this should be a filtering capacitor. So there is 0.6 volts. So obviously, this is not enough. I can measure also the voltage across the power supply filtering capacitor, or on the secondary side, there is a voltage of 10 volts across the two secondaries. So 5 volts, so I think it is not enough. I am increasing the voltage. I have 12 volts across the filtering capacitors. I am going to do a measurement of the power supply voltage. It is 73 volts, so obviously this should be 115. So I will adjust the power supply in order to have 115, 107. This should be okay. 120. I will desolder the wires of one board and I will do the reverse engineering of this board. I suppose that it is the servo control loop which drives one AC motor, but as there are several wires, I would like to see where the motor is connected, where is the input, and if there is an enable signal and stuff like that, it will be easier after. Okay, so the power supply is minus 20 and plus 20 volts. So we have the power supply on these terminals here. So this will help for the reverse. Now this is one board. It's not complicated. 6 transistors, 1 transformer and a few passive parts. I don't know if we can remove one transistor. Yes, we can check the date code and the reference of this transistor. It's difficult to say. Nothing is written. It is written T5 here. Nothing more. There are different parts. This one has a golden bottom plating here. So let's see if we have more chance with this one. This one will be difficult to remove. Maybe this one. Yes, we can see something, but it is hidden by this spacer here. The spacer seems stuck or glued to the case of the transistor. I will see, I just need to check if there are NPN or PNP, it will help. So probably they are the same type. I can check. Okay, so this one seems to be a NPN transistor. And I assume that the golden ones are PNP. Yes, it seems. Okay. Okay, so we have 2 PNP transistors here with the golden plating and 4 NPN transistors. So this should be just an amplifier. There's probably a push-pull output or something like that, and a driver transformer to drive the output transistors, and maybe a differential amplifier on the input or something like that. So this will not be complicated. I think in half an hour I have done the reverse engineering. This is a schematic diagram of one board. This is an amplifier. This amplifier permits to drive an AC motor. The input is here, the output is here. So the gain is defined by the ratio of these two resistors. So the gain is approximately 60 or something like that, 70. There are 2 stages. The first stage permits to drive the primary of this transformer. The voltage at the emitter of this transistor is minus 0.7 volt if we assume that the DC voltage on the base is 0 volt. This negative voltage is provided by this pull-down resistor here, connected to a negative power supply. The second side of the primary here is connected to the collector of this transistor. So when the transistor is off, the second side of the primary here is connected to the collector of this transistor. So when the transistor is off, this terminal will be connected to the negative power supply through this resistor. And when the transistor is on, this side is connected to the positive power supply. So at this point, we find a voltage which can be positive or negative. This arrangement permits to avoid the saturation of the transformer. There are 4 identical boards on this instrument. This instrument works like that. We have an AC motor here, which is connected to the pointer. It can be, for example, the horizontal horizon. And there is this amplifier, which permits to drive the AC motor here, with a reference winding. This AC motor is linked to a resolver, with also a reference voltage, the same. I made a mistake. The reference winding actually is not connected to the reference voltage. The reference winding is connected to the input of the amplifier, like that. And the input of the resolver here is connected to the input of the instrument on the rear connector. And the drive of this instrument is to use another synchro resolver here, which will be connected to this instrument with the reference winding here, which should be the same, of course, than the reference winding of the motor. Okay, so the goal of this system is to have a 0 volt AC at this point here, and in order to get a 0 volt AC on the reference winding of this resolver, we need to have a particular angle of this shaft depending on the AC voltages which are present on these 3 terminals. So actually, when there is a change of the position of the shaft of this resolver, there will be also a change of the position of the shaft, which is linked to the pointer here. So it is difficult to find the pinout of this thing, because there are several wires. So what I did is to try to find 3 terminals on the rear connector here, which have the same resistance, because actually this resolver here, there are 3 coils, and between each point we should find the same resistance. So I did this measurement using a DMM, and I found that these 3 terminals here have the 3 identical resistances, which is approximately 200 ohms. Obviously there are at least 3 others synchros which should be connected to this connector, but it is the first I found. So I have connected this resolver. I have connected the reference winding of this resolver to the power supply. Okay, so let's turn on the power supply. So you can see that the horizon follows this resolver. So it is possible to do the same for the 3 other stuff. I will try to find the other corresponding terminals in order to drive the vertical position of this horizon here. I assume that the resolvers are identical, so I will search for a resistance of 200 ohms or something like that, and maybe they are close to this one. Okay, I have another 205 ohms. Fantastic, so this is GH and D. Okay, so let's connect this thing here. Okay. There is something wrong. We change the position of one wire maybe I am in a forbidden position. Okay, it's better. This was the teardown, a small reverse engineering, and the test of this Director Horizon H6. So you can see with little effort it is possible to use this instrument. I spent about 3 hours for that. Thanks for watching, see you next time, bye.